Okay, welcome to Math Studies Unit 1, Topic 2, Exponents and Scientific Notation. Most of this should be review, but let's see what we have. So an exponent is the same as writing a number times itself a certain amount of times. So 7 to the 4 is just 7 times 7 times 7 times 7. And then we have some rules with them. So obviously if we have x to the 1, or any number to itself, that's just the same as the number. So for example, 6 to the 1 is the same thing as 6. Okay. For the next one, this one's a little trickier, x to the 0, or anything to the 0, is 1. For example, 7 to the 0 is 1. There are lots of proofs and reasons to explain why that is true. However, I usually go with, think about something like x to the 0. Well, in front of it, you'd have an invisible 1. Well, when you say you have x to the 0, it means you have 0 x's. So what's left? Just a 1. Okay. The next one is any number to a negative 1. And what that means is that that number is in the wrong spot. So I'm actually going to do this. Let me check my notes. Yeah, okay. So if we had x to the negative 1, it really means that the x should be in the denominator. Or if we had something like 1 over x to the negative 1, it means that variable or number in the denominator should be in the numerator. I call that a ticket to ride. It was in the wrong spot. Once you moved up, it got on the train, moved up, got on the tracks. It's now used up its ticket. So for example, 4 to the negative 1 is the same thing as 4 to the negative 1 over 4. And then the whole thing needs to come down. So that's 1 over 4. And the 4 has now lost the negative 1 ticket. Now remember, you could put a little 1 here, but just like up here, that's just the same thing as 1/4. Okay. For the next one, I'm going to show you the multiplication rule. If we have the same base, x to the m times x to the n, we are going to add the exponents. And I often forget this rule, so I test it. Let's say I have x squared times x cubed. Well, that just happens to be the same thing as x times x for the x squared times x times x times x for the x cubed. That's called expanding. And then if you count them up, 1, 2, 3, 4, 5, that's the same thing as x to the 5th, or 2 plus 3. Okay. The next one that is similar to that is x to the m raised to the n. And in this case, instead of adding the exponents, we are going to multiply them. And again, I often would mix these two up, so I test it with a simple case. So my simple case may be that I have x cubed squared. So I have this stuff in the middle. I have this x cubed 2 times, right? Because a squared means it's something times itself 2 times. So x cubed times x cubed times x cubed, and I'm going to make it bigger. Oops, excuse me, that's just twice, right? 2 times. So I've got it 2 times. And then I could expand it. So that is the same thing as x times x times x. That's for this one. And then we've got to use this one 3 times. X, 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 and if you count them up, that is x to the 6, which would have been the same thing as 2 times 3 or 3 times 2. Okay. The next one, we've done raising to a power and multiplication. Now we are going to go ahead and do division. So if we had x to the m over x to the n, okay, that is, now think about it, when we had multiplication here, we added, so divide is going to go with subtract. That's the same thing as x to the m minus n. And let's look at an example of that. What if I had x to the 6th over x squared? Okay, I could expand both the top and the bottom. That's 6 x's multiplied together on the top. 4, 5, 6. 2 on the bottom. And then think about it. X divided by x is 1. It goes away. It goes away. And we are left with x to the 4th. So which would have been the same thing as 6 take away 2. The same thing would work if the smaller number was on the top. What if we had 3 x's on the top and 5 on the bottom? They're still going to cancel out, but instead on the top we're left with an invisible 1, because we did have a 1 under here. We just don't write it. A 1 over x squared. Now if you'd subtracted these, 3 minus 2 would have given you negative 2. So let me write that again. X to the 3 minus 5, there we go, that's better, would have given you x to the negative 2, but then that means that this numerator is in the wrong spot, which would have brought it as 1 over x squared. And you never leave an answer with a negative exponent. Okay, that'll catch you on your worksheet. All right, so the next one is a combination of everything we've been doing. What if I had x times y to the n? Okay, well that's the same thing as x to the n, y to the n. That's the shortcut. And basically what we did was we multiplied, we put this here and this here. Okay. And if we did it with an example, we could have had x, y cubed, which would have been x cubed. And you can go ahead and expand it. We had xy times itself 3 times. So xy times xy times xy. That's 3 x's and 3 y's. Okay. Another example of that would be, what if I had, and this is the same rule, but just expanded. What if I had x squared y to the 4th cubed? We're still going to multiply. We're still going to distribute, but we have to multiply. So that would be x. 3 times 2 is to the 6th. And let me show you why before I show you that. So this is just one more example. I didn't have enough room. If it's a little trickier. In fact, I'm sorry, I'm going to move this right here and give you another version of the rule. Okay, and that version would be this. What if I had x to the m, y to the n, b? Then that'll be x to the m times b, y to the n times b. So we still multiplied it on, but we have to take count of the exponents already there. And this is why that works. Okay, we have this stuff 3 times. So we have x squared y to the 4th times x squared y to the 4th times x squared y to the 4th okay, which is x, x, y, 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 y. And you could keep counting them up. And we'd get 1, 2, 3, 4, 5, 6 x's. And 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 y's. Okay, or you could just multiply this times this and this times this. Your choice. On the harder problems, it might be actually better to expand everything. All right, I have a couple more for you. That same rule works for multiplication. So if I had x to the y over n, okay, and it could have, this really is just an invisible one, so it could be the one like here or here. It's the same rule. We are just going to distribute it, and we have, that's x to the n over y to the n. So for example, x over y squared is x squared y squared. And if we'd had something a little more complicated, maybe like 2x over y cubed squared, it's still the same thing. Okay, we could expand it. We have this stuff 2 times, so we have 2x over y cubed equals 2x, or sorry, times 2x over y cubed. And then if you multiply that, that's 2 times 2, or 4. X times x is x squared. And we have 1, 2, 3, 4, 5, 6 y's. That would have been the same as saying 2 squared is 4, x squared is x squared, and 3 times 2 is 6, y to the 6th. So you can expand it as much as you need to, or as little as you need to. All right, 2 more. Okay, it goes along the lines with this one, x to the negative 1. That is the same thing as x to the negative anything. It still just goes down to the bottom, or vice versa. So for example, x to the negative 3 is 1 over x cubed. Or you could get really tricky and have something like x to the negative 2, y to the negative 4, maybe a z on top, a z cubed. Well, this one has a ticket to ride because it has a negative, and this one has a negative, so they need to switch places. Notice the z doesn't have a ticket, so it's in the right spot, so it's just going to stay there. And we now have y to the 4th, it's used up its ticket, z cubed all over x squared. And I know I'm going fairly fast, but this should be reviewed from Algebra 2 or secondary. So come see me if you need more help, and we'll practice it in class. Here's the very last one. And this is the rational exponent rule. Okay, we have x to the m over n. And that is the same thing.